Welcome to my channel, guys, and today I'm going to talk about momentum and impulse. Okay, first, what is momentum? Okay, basically momentum is when an object or mass is in motion. So the formula for momentum is P. So the symbol for momentum is P equals to mass times the velocity. So for example, if I have a ball which is 1 kilogram and it's moving with the velocity of 1 meter per second, we say it has momentum of 1 kilogram meter per second. Yep. Okay, so the unit of momentum is kilogram meter per second. So momentum is actually a vector quantity because velocity is a vector, right? And mass is a scalar quantity. So when a scalar quantity multiplied by a vector quantity, it will be a vector quantity produced. So yeah, it is really important to know that momentum is a vector quantity because when you sub into the equation, the positive and the negative signs is actually quite significant. Okay, now we're going to talk about impulse. The formula for impulse is J equals to Ft. I know some people might use I as the symbol for impulse, but I choose to use J. It's up to you actually. It doesn't matter. Okay, so impulse is actually come from Newton's second law, which is F equals to change in momentum divided by the change in time. Okay, so I know a lot of people might think that no, Newton's second law is supposed to be F equals to ma. But actually the original definition of Newton's second law is supposed to be force equals to the rate of change in momentum. Okay, so since we know that A is equal to the change in velocity divided by the change of time, so if we sub this into the equation, it will become F equals to ma. This is where F equals to ma comes from. But today we're not going to talk about F equals to ma. We're going to talk about impulse. So if we multiply both sides by t, the delta t, we get F delta t equals to m, the change in velocity. Okay, so this is the change in momentum. Okay, so since we know that impulse is actually equals to force times time, right? So Ft will equals to J equals to change in momentum. So impulse is also actually equals to change in momentum. Okay, here we have some example. So imagine we have a ball of 1 kilogram. Yeah. Okay, and then it is at rest, which means the initial velocity is 0. And I try to push this ball with a 5 Newton force for 5 seconds. First, we need to find what's the impulse. Okay, the impulse is easy. So we just need to use J equals to Ft, and J equals to 5 times 5. So it's equal to 25 Newton second. Oh, the unit for impulse is Newton second. And then we want to know, after we apply this force, this 5 Newton force, what velocity will the ball move? So we can use J equals to the change of momentum. And delta V is actually the final velocity minus the initial velocity. Okay, here's the thing that you need to know. My final velocity, I put it as v, so this is actually the final velocity, and this is the initial velocity. So the mass we know is 1 kilogram, right? And we need to find the final velocity, and the initial velocity is 0 because it's at rest, right? So u equals to 0. So impulse is 25, so we know that the final velocity will be 25 meters per second. Another example which is kind of important, which is where we have a wall and a ball. Let's put it 1 kilogram again. It's much easier in calculation. Okay, so first this ball is moving with 5 meters per second. Okay, after that it hits the wall and rebounds. So it rebounds with 3 meters per second. Okay, so now we need to find the impulse of the ball on the wall. Okay, so first this is kind of tricky, so you need to know which is on and which is by. What I mean is, okay, there are two impulses in here, which is the impulse on the wall by the ball, which is BW. Another is impulse by the wall on the ball. Okay, so there are two impulses here, and these two impulses actually same in magnitude but different in direction. One might be positive and one might be negative, depends on which side you set as positive. Okay, of course I'll set right side as positive. If we want to calculate the impulse by the ball on the wall, we need to put the velocity and the mass of the wall. We usually put the second one, the second letter. This is what I do, this is how I do. I usually put the second one, and then we know the subject will be the second letter one. But it's impossible to know the mass of the wall and the velocity of the wall because they remain unchanged. Their final and initial velocity just 0, nothing. So the impulse of BW will naturally become 0. So what we can do is actually find this impulse, the impulse on the ball by wall. Okay, so here we put the mass of the ball and the velocity of the ball. Okay, so we know the mass of the ball is 1 kilogram. Since we take right side as positive and this final velocity is towards the left side, so we need to put a negative on it, minus 5. So the impulse will be minus 8 Newton second. Since we want to find the impulse on the wall by ball, right? So we know that JBW is actually equals to JWB. So naturally we know that JBW will equals to 8 Newton second. And it's positive because it's going to the right. And then another thing that I want to talk about is conservation of momentum. Okay, what is conservation of momentum? Conservation of momentum is basically means the total momentum before impact is equal to the total momentum after impact. Okay, usually we use this conservation of momentum when there are two or more objects collide together. For example, we have ball A and ball B, right? And before it collides, it has initial velocity. And after it collides, we will have final velocity for A and B. So the equation to find this is MAUA plus MBUB equals to MAVA plus MBVB, which is the initial momentum of A and B, is equal to the final momentum of A and B. Momentum can happen in 2 dimensions too. So if you need to do the calculation in 2 dimension, 2D, we need to use something called vector. If we do a momentum with a vector, it's actually not that complicated as you think, because the formula we use is actually still the same. The only thing that changed is you need to put a dash. So which means all the vector quantity will appear. I will also put some example when we have vector in this kind of question, and it's actually not as hard as you think. It's quite easy, I think, as long you do it step by step and use all the information in the question. Okay, I hope you learned something in this video, and I hope I see you in the next video. Okay, see ya.